In this video, we're going to have a look at how to solve algebraic equations that contain fractions. However, before we start solving algebraic equations with fractions, I'm going to remind you how to simplify algebraic expressions with fractions. The first thing you need to remember is that when working with fractions, it helps if every term is written in fraction form. Next, you need to determine the lowest common multiple or the lowest common denominator. In our case, we are focusing on 4, 3, and 1, which have a common denominator of 12. The next step is to change every single fraction to fit this numerator of 12. So my first fraction, the denominator still had to be multiplied by 3 to get 12, and now we have to repeat that in the numerator, and that will give us 3x. The same happens with our second fraction, which has a denominator of 3 and should be multiplied by 4. If we repeat that in the numerator, we will get minus 8x. And looking at the last fraction, the denominator is 1 at the moment, so we still need to multiply that by 12. And repeating that in the numerator will give me a new value of plus 60. Lastly, we add up all the like terms. In this case, we have 3x minus 8x, so we will have minus 5x plus 60 over 12. When we now have an algebraic equation instead of an expression, the instruction will be to solve x instead of simplify. The first few steps, however, are exactly the same, so I'm going to start off writing all terms in fraction form. Next, I'm still going to determine the common denominator, but now that denominator will be on both sides of my equation. Next, I'm once again going to change the numerators according to the new denominator. So the first fraction I still had to multiply by 3, and repeating that at the top, I will have 3x. The second fraction of 3 still needs to be multiplied by 4, which I also repeat to get minus 8x. And on the right hand side, the denominator has to be multiplied by 12, and repeating that at the top, I will have 60. Up to now, the steps for the equation and expression were exactly the same. But now we have a few extra steps to solve the equation. In an equation, we know that the value on the left is equal to the value on the right. At the moment, the denominator on the left is exactly the same as the denominator on the right. So I can make the conclusion that the numerator on the left-hand side should also be equal to the numerator on the right-hand side. This means that in my next step, I can say that 3x minus 8x is equal to 60. Another way to look at it is to get rid of the divided by 12. On the left-hand side, I can multiply by 12 because 12 divided by 12 is 1. But because this is an equation, if I multiply on the left, I have to multiply with that same value on the right. And again, 12 divided by 12 is 1. So now we are left with minus 5x equal to 60. And once I've divided both sides by minus 5, I can say that x is equal to minus 12. Let's have a look at another example. Again, when I have fractions, I start off ensuring that all terms are in fraction form. Next, I need to determine the lowest common multiple for both sides of this equation. That common denominator will be 6. And next, I need to determine the equivalent fraction for each of the original fractions with a denominator of 6. So the first fraction needs to be multiplied by 3 in the denominator, and when we repeat that in the numerator, we get 9x. The second denominator has to be multiplied by 2, and repeating that at the top, we will get plus 4. On the right-hand side, the first fraction's denominator has to be multiplied by 6, and multiplying the numerator by 6 will give me 6x. The last fraction is already on 6, so that will stay minus 5 in the numerator. And now, because the denominators are the same, in my next step, I can make the conclusion that the numerator left should now be equal to the numerator on the right. Now we have a normal linear equation, and I'm going to get all my x terms on the left-hand side, so the plus 6x that's on the right will be subtracted on the left. On the right-hand side, we have the constant of minus 5, and the plus 4 on the left will be subtracted on the right. Now we have 3x is equal to minus 9, and once I've divided both sides by 3, I will end with x is equal to minus 3.